Welcome back. Let's continue our lecture on chemical properties of group 1 elements. Group 1 elements. Okay, so the fourth property we'll look at is their reducing ability. The group 1 elements or alkali metals are excellent reducing agents. What does that mean? Just for a little bit of context, let's define what reduction is and a reducing agent is. Now, in terms of electron transfer, right, a reducing agent is an agent that induces the reduction of another substance and itself being oxidized. So when you have a chemical reaction and a species is oxidized, right, it is the reducing agent, because what it has done is that while itself being oxidized has caused the reduction of another species. So reduction in terms of electron transfer is gain of electrons, right, while oxidation is loss of electrons. So it means that the species that is oxidized is the reducing agent, and the species that is reduced is the oxidizing agent. So for group 1 elements to be reducing agents, it means that in chemical reactions they must be what? They must be oxidized. And what is oxidation? It is loss of electrons. Because group 1 elements have one outermost electron, and it is not reasonable for an atom to give group 1 elements 7 electrons so that they will have a complete octet structure. But then it is reasonable for group 1 elements to lose one outermost electron to have a stable octet or duplet structure. So group 1 elements lose electrons readily in chemical reactions. And because they lose electrons, it means they are readily oxidized. And if they're readily oxidized, what agents are they? They are reducing agents. So they are the best reducing agents you have in the world, because they are group 1, they have just one electron, and they easily lose that one electron. What other property of group 7 elements do we have? Let's talk about their carbonates. I must be frank with you, there is a lot of information to talk about here, but we'll keep it as simple as possible so we don't cluster or we don't cram in information into your head, right? Now, talking about their triazocarbonate 4 salts. Their triazocarbonate 4 salts are thermoresistant. What does this mean? It means that triazocarbonate 4 salts of lithium, sodium, potassium, and others are thermoresistant. So when you decompose this in the presence of heat, it doesn't decompose. It remains as that. It is thermoresistant. It is stable to heat. When you do same for this, it is stable to heat. This also is stable to heat. Now, stable to heat means that does not necessarily mean that it can't decompose. It just means that it requires very great deal of temperatures, high amounts of temperatures. We're talking about a minimum of 700, 800 degrees Celsius. Some can even decompose well above 1000 degrees Celsius, which is very high. So for that reason, we said they are stable to heat, right? Means they do not decompose upon heating. And that's it. It's all, the carbonate salt of group 1 are thermoresistant. What can we say about the hydrogen carbonates? The hydrogen carbonates decompose upon heating to give. Now, let's see the product it gives. If you have sodium carbonates, as an example, sodium hydrogen carbonate, this decomposes upon heating to give what? To give sodium carbonate, right? It gives us sodium carbonate. It gives us water, H2O, right? And it gives us oxygen. So let's see if that can be balanced. This is 2, right? So you have 2 sodium atoms, 1 carbon atom, this abi. So how do we balance this? Okay, sorry, it gives us carbon 4 oxide, CO2. Okay, is this balanced now? 2 carbon atoms, 6 oxygen atoms, 2 hydrogen atoms, and that. So that's what you get. So it gives us to give the metallic carbonate, water, and carbon 4 oxide gas. So this is what you have. And this reaction happens even for sodium and even for lithium and potassium. The same reaction happens. So the hydrogen carbonate decomposes upon heating to give that. What other chemical properties do they have? What about their nitrates? When you talk about heating their nitrates, or you say triazonitrate 5, are thermolabile. Their nitrates are thermolabile. What does this mean? It means that they decompose upon heating ordinarily, unlike these ones that are resistant to heating. Their nitrate salts are not resistant to heating. So you can decompose, they decompose to give, right, a dioxonitrate 3 salt, and give off oxygen gas. All right, I hope these informations are not too much. Now, let's see. If you have sodium nitrates, this is a triazonitrate 5 salt. The triazonitrate 5 salts are thermolabile, which means that they decompose upon heating to give a dioxonitrate 3 salt. Right? A dioxonitrate 3 salt, and it gives us oxygen gas. This is one way you can prepare oxygen gas in the laboratory. Thermal decomposition of a triazonitrate 5 salt of group 1. So when you decompose the triazonitrate 5 salt of an alkali metal, what you have is you produce a dioxonitrate 3 salt, right, of the metal, and you give off oxygen gas, as you can see. Okay, what if we have for potassium, KNO3? It decomposes upon heating to also give us a dioxonitrate 3 salt, and it gives us that. So let's say, are these equations balanced? No, they are not. Introducing 2 here, 2 here, does it make that balanced? Yes. Introducing 2 here, 2 here, does it make that balanced? Yes. And this is it. All right, so this is another chemical property of group 1 elements. Number 8. Oh, sorry, that should be in blue. Still on group 1, it's another point says, now we've talked about their carbonates, we've talked about their nitrates, right? Now, it is important to note that all salts of alkali metals, all salts of alkali metals are water soluble. So what does this mean? It means that be it a nitrate, a chloride, a carbonate, a sulfide, or whatever it is, a sulfate or whatever it is, right? Now, when you decompose these salts in water, they dissociate easily and they dissolve in water to give their ions. So, what sort of group 1s do we know? We mentioned all these are salts. Let's do it in, all these are salts, right? This is a salt. This is a salt. Sorry. Okay. This is a group 1 salt. And we've been talking about salts for an appreciable part of this lecture. So now, when you see their salt and you decompose them in water, and then you're asked to identify whether or not that salt will decompose in water, what do you need to look out for? At least for the cations. The first thing you need to check is, are they alkali metals? If the answer is yes, then they are soluble. If the answer is no, you also need to check if the cation is made of ammonium. Because all alkali metal salts, that is when alkali metals are the cations, and ammonium salts are exclusively soluble in water. And then if the answer is no, then you can consider the anion. We gave that lecture on acid, base, and salt, so you can refer to that. So all group 1 salts are soluble in water. All right, guys, let's take a quick recap of all that we mentioned for chemical properties of alkali metals. So looking at the chemical properties of alkali metals, we started with the number of outermost electrons they have, and we said since they belong to group 1 of the periodic table, it means they all have 1 outermost electrons, hydrogen inclusive. But then hydrogen is not a typical group 1 element, right? We explained why it is put in group 1. Okay, then we talked about the reducing abilities, that group 1 elements are excellent reducing agents, which means that they are readily oxidized on the spot by the loss of the one valence electron they possess, with an exception which is lithium, because it has a relatively small size and the outermost electron receives an appreciable amount of force of attraction from the dense nucleus, right? Then we talked about the ability to lose an electron to form a unipositively charged ion, right? We talked about the fact that they have one valence electron. We talked about the fact that they are triazocarbonate. 4 salts are thermoresistant, which means that when you apply heat to the triazocarbonate 4 salts of alkali metals, they do not decompose, right? We talked about their hydrogen carbonate salts, and we said that the hydrogen carbonate salts are thermolabile, which means they can decompose upon heating to give us the triazocarbonate 4 salts, to give us water and give off carbon dioxide, right? We talked about the fact that they are called alkali metals because they can react with water to produce an alkali and liberate hydrogen gas. And then we said to carry out this experiment, you must ensure that the water to use in this experiment is very cold, because the reaction is highly exothermic. And if you're dealing with warm water or with hot water, you could have an explosion spilling the concentrated alkali produced on your face, on your skin, or on any delicate surface. And then you must also ensure that you use an all-glass apparatus. You're using an all-glass apparatus so as to contain the large amount of temperatures that will be released in the case of this experiment, right? We said all their salts are water-soluble. So all salts of group 1 and ammonium are water-soluble. So guys, that's pretty much it about the group 1 elements. Remember, they're called group 1 alkali metals, or you call them the lithium family, because lithium is the first member of the group. In the next lecture, we shall move to group 2 elements, and it will follow the pattern, okay, of our lecture for group 1, and then we give the properties of group 2. So thanks for sticking with us. I hope now you understand what group 1 elements are. You can describe these elements and give some of their properties. So join us in the next lecture when we talk about group 2.